Okay, so example 3, and let me just get my arrow here. Okay, so a new car worth $2,400 is depreciating in value by $5,000 per year. After how many years will the car's value be $9,000? Now, I hope when you're reading this, you are maybe scratching your head and thinking, does this make sense? And it actually doesn't make sense. I have a typo here, which I guess is good because it doesn't make sense, and I want you to see that it doesn't make sense. First of all, I want to know where this dealer is that a brand new car is only $2,400. Uh, so that is not $2,400. That is $24,000. And it's depreciating in value, meaning the value is going down, right? After you put miles on a car and, I mean, you use it, it becomes a used car. So it wouldn't be fair to sell it for the original price after, a couple of years. And this guy here, this is not 5,000. This is actually, I want this to be 3,000. Okay. Because the question asks for, let me again go back to the arrow. After how many years will the car's value be $9,000? So how long does it take how many years does it take so that the car is worth 9,000 instead of 24,000? And of course, the 2,400 wouldn't work because 2,400 is less than 9,000. Here we're actually appreciating in value, right? We're adding, but we don't want to add. We want to depreciate. Okay, so now let's solve the problem. So what is the unknown? What don't we know? Well, first we have to find what we don't know, and then we want to define it using an algebraic expression. So after how many years will the car's value be $9,000? So I'm just going to let x be the number of years. Let's see how to, well, you can paraphrase. Let's see, after how many years will the car's value be $9,000? So let x be the number of years. Okay, it will take, right, for car's value to be $9,000. And that's a comma. Okay, that doesn't, let me erase that. Okay, so that's $9,000. So check. That's already 2 points or a point on your quiz. Okay, step 2. If necessary, write an expression for any other unknown quantities in the problem, of course, in terms of x. Now, I hope you can see that here there are no other unknown quantities. So here, I mean, you can just say no other unknown quantities, right? Because all we want to find is, we just want to find the number of years it'll take for the car's value to be $9,000, right? Just the number of years. Here we're not asking for example, the last example, in example 2 was the total cost of, right, Health Club A, and then Health Club B, right? There was 2 other unknowns. In example 1, the bachelor's degree, well, the bachelor's degree was the unknown, but the master's degree was that 2x minus 49,000. So here we don't have anything else. So you can just write no other unknowns, and that's a point because you know that there's no other unknowns and you're communicating to me. And write a mathematical model, right? An equation that models the situation. Okay, so here we have, we're starting with x, right? That's the, well, no, we're not starting with x. Let me erase that. And go back to blue. So what's the car's value when it's brand new? Well, it's 20. Oh, I guess I'll stick with, okay, I'm going to erase that. I want to do black. Okay, it is $24,000, right? And then it's depreciating, right, in value every year. Every year it's losing $3,000. So minus $3,000, right? Every what? Every year. So, well, our year was, we let X be that. So I'm just gonna write X, right? If, let me just go to the arrow here, right? If X was 1, then the first year they would subtract 3,000 times 1, which is 3,000. If X is 2, right, 2 years, then they would subtract 6,000. If X was 3, they would subtract 9,000. And then, I mean, you can kind of explore and see a pattern, you'll find out what X is. But the goal of this class, right, it's an algebra class, so we want you to use algebraic equations to solve this problem. So this is our algebraic expression, and let me go to black. And after how many years will the car's value be? $9,000. So that's our model. And now we want to solve this. I'm just going to rewrite this below. And let me just move up a little bit. So again, we want to solve for X, right? That's the goal. So we want to isolate this guy. And, oops, got used to this, this app. Again, we have a constant here. We have a constant here. They're on opposite sides. We want them to be on the same side. You can bring that 9,000 over, but I would bring the 24,000 over because X is already on this side and we want X on one side and the constants on the other. So I'm going to subtract 2,400 from, well, not 2,400, 24,000 from both sides. So let's see, let me use this color. So minus 24,000 minus 24,000, and let me just switch colors. Whoops. Right, and then we are just going to add vertically, right? This is what we've been doing with the other equations. And so let's see if I want to pick another color. Oh, I'll stick with, it should be black. Okay, so that's 0, which we want. So we have negative 3,000, X equals, right? And then $9,000 minus $24,000 gives you negative $15,000. So again, this 3,000x really means 3,000 times x. So to solve for x, you want to do the inverse, right, or the opposite operation. So we are going to divide both sides by negative 3,000, right? That's the coefficient. And I want negative because I want this to become positive, right? And a negative, right? A negative, divided by a negative, right, is a positive. And if I do it to the left, I've got to do it to the right to stay balanced. And then this is a big 1, right? 1 times x is x. And let's see, and actually, that should be a negative 2. Oops. And then this is nice, right? Get a bunch of zeros, and 3 goes into 15.5, and a negative again, divided by negative is a positive. And notice when I forgot this negative, I knew I had to go back because I would have gotten negative 5, and it would take negative 5 years. That just doesn't make sense. So again, when you make mistakes, it's good because it makes you think and go back. So x is equal to 5. 5 what? 5 years. And that's it. Step 5 is check the solution. Does it make sense? Well, here's our, just getting the arrow again. here's our equation. So let's actually substitute that x and see if we actually do get $9,000. So let's see. And again, this is our blue, right? And we just want to substitute that guy right back. So we have 24,000 minus 3,000 times 5, right? Does that really give me $9,000? And 24,000 minus 15,000, and that actually does give you $9,000 if you work it out. And again, this 3,000 times 5, right? That, I mean, multiplication is just repeated addition. This really means 3,000, right, plus 3,000 plus, dot, 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 plus 3,000, right, 5 times, right, because we have, this is for year 1, right? After 2 years, they subtract, the whole 3,000 plus 3,000, and finally 3 times 5 is the 15. So hopefully that makes sense. So that's it for example 3.